Hello guys, my name is Kit, and in this video I'm going to do 15.57 from the chemistry textbook. So for the reaction, that chemical reaction, Kc equals 280 at 150 degrees Celsius. Suppose that 0.500 moles of IBR in a 2.00 liter flask is allowed to reach equilibrium at 150 degrees Celsius. What are the equilibrium concentrations of IBR, I2, and BR2? Alright, so let's start this. So let me see, I know that, so Kc equals 280 degrees at 150 degrees, is allowed to reach equilibrium at 150 degrees Celsius. Okay, so for this, it looks like I'm gonna have to use an ice table. I don't really know what that stands for, but that's what my teacher calls it, so there you go. So first, I'm gonna write initial. Zoom this in. Initial, delta, and final. And this is gonna be the concentration, and then we have IBR. You have IBR, I2, and let me put some more space in this. IBR, I2, and BR2. Alright, so what we know is that we know 0.500 moles of IBR in a 2.00 liter flask. So what that means is that we could calculate the initial concentration of IBR. So to do this, we gotta do 0.500 divided by 2 to find the molarity. So I'm gonna do that in my calculator here. 0.5 divided by 2 is 0.25. So it has an initial concentration of 0.250 molarity. Alright, and so I2 and BR2 is 0 because the question doesn't state that there is any initial concentration for these. And now the next thing that we need to do is we need to find an equation to solve for Kc. So we know that the IBR is the concentration with is the only thing with the concentration. So let me look back at this. So we know that IBR is the product and that it's the only thing that's in this reaction right now. So it's going to turn back into I2 and BR2 to complete the equilibrium. Okay, so what that basically means is that the delta will be a negative number, and that the I2 and BR2 will have a positive delta or change. Okay, so we know that so we know from this that the molarity ratio of IBR2 and IBR is 1 to 2 and 1 to 2 and 2 to 1 and 2 to 1. So what that means is that the change of IBR is going to be 2 times the change of BR and I. So it's going to be 2x, and this is going to be plus x. Alright? Okay, so next we need to make the final equations. So the final equation is 0.250 minus 2x, and the final for I2 and BR2 is just going to be x and x. Okay? So now the next thing that we need to do is we need to solve for 280, which is the equilibrium concentration. So 280, which is the concentration, equals, and we know from this that the product is IBR and the reactant is I2 and BR2. Alright, so we're going to have IBR, which is this here, 0.250 minus 2x, and since it has a coefficient of 2, the this thing right here is going to be to the power of 2. That's going to be divided by the reactants, which is x. Oops. Oh yeah, this is a plus. Should be an x. So x. So it's going to be x times x, which is the same as x squared. Alright? Okay, now we need to do some algebra to find x. So let's do this. 280 x squared equals, so it's 2.50. Just gonna do this real quick. 0.250 squared equals 0.0625. 250 times 0.250 0.25 times 2, which is 0.5, and that's negative. It's gonna be negative x. Then this is gonna be plus 4x squared. Alright, so now I simplified it to this, and let me double check if that's correct. 0.250. Okay, yeah, that seems correct. Minus x. Yeah, that's correct. Okay, so now we need to solve for x squared. So we're gonna put all these values on one side. You guys should know algebra. 625 minus x. So minus 280x squared. This is going to be negative 276 x squared. Okay, and now we need to use the quadratic formula, which is minus b. So this is b minus negative 1 plus minus square root of square root of b squared. So b squared is negative 1 squared minus 4 times a, and this is a, so it's negative 276 times c, which is 0.0625 divided by 2a, and 2a is 2 times negative 276. Okay, so this is x equals, so we'll get x equals, let me put this in my calculator. I'm not going to do all of these calculations, I'm just gonna solve it using my calculator because I'm lazy. Equals 0.0625 minus x minus 276 x squared. Okay, let's see. And the value is x. Alright, so I got x. X equals negative 0.016968 and 0.013345. Alright. Okay, so now the problem is, which value do we use? So to do this, we need to just plug these in our head to see which one would make a negative concentration value. So we know that if we plug in this value into the x here, this is going to be a negative, and that doesn't make sense. So we need to use this value instead. So we could omit this one and we'll just use this one. Alright, I should move this down. Okay. There we go. So if we solve for this, so it's going to be IBR 250 minus 0.250 minus 2 times 0.013345. This equals oh wait, I'm just gonna do it later. I2 and BR2. Oh, and this is just gonna be x, so this is gonna be 0.013345, 0.013345, and let's do this one. 250. Oops. 2.250 minus 2 times 0.013345. I got 0.22331. Alright, and these are the concentrations. But we're not done yet because we need to figure out the sig figs. Alright, so for this you need to think about which values are being used. And okay, so we know this is 2. We know it gives us 280. 280 has 2 sig figs, and we solved for x using it. So these should be 2 sig figs. So this one, it should be 0.013, and this should be 0.013 as well. So MI2, MBR2, and this one should be minus 2x 0.0. Think about this. 0.133. This should be rounded to the third decimal place, and the third decimal place is this, so this will be 0.223 MIBR. Alright, and those are the answers. So this and this. Those are the equilibrium concentrations of IBR, I2, and BR2. So let's check these real quick. Answers. Please be correct. Please be correct. Okay, so yep. So 0.223 M for IBR, 0.223 M IBR. Let's see. I2 BR2 0.0133. This is 0.013. Oh, so it is 3 sig figs, which is odd because it should be 2 sig figs. Well, I guess the book got it wrong, but I'll just do this, you know, whatever. Okay, so that's how you do 15.57. I hope that helps. I know it's confusing, but you could just rewatch it. Thanks for watching.